Alright, we have a situation with carbon A, and then we have organic compound A, compound B, C, D, compound E, and compound F. And then we require in question 2.1 to give the late of each of, let's say, hydrocarbon. That is 2.1.1. So what is a hydrocarbon? And then it's only, hydrocarbon is a compound composed only of carbon and hydrogen only. So we can see A, we have oxygen there, C, there's oxygen, E, there's oxygen, D, oxygen, and even F has carbonyl and oxygen. So our option would be B. So that's B. So alcohol, we can go to the formulas. So checking through, see that D is an alcohol. We can draw the structure just to prove that. That is alcohol there. We have 3 carbons, which is propanol. So that is alcohol. Just to prove, make sure that you draw a structure so that you know exactly what the compound is. It should correspond the ratio between the carbon and other elements. And then we have F because of that function group there, that's ester. So F is ester. And then we go to IUPAC name for A. Let us go what A looks like. A, that is compound A. It's very important that we draw the structure in order to understand. But then A there, let's look at the structure of A. First, the chemical formula for A: CH3, CH2, CH2 again, and CHO. So that structure will mean that we have how many carbons we have? We have 4 carbons, and then we have CH3, and then we have, I think, double bond with oxygen, and then we have all the hydrogens on other carbon atoms, and then this is going to be alcohol, aldehyde, not alcohol, aldehyde, because of the carbonyl group. So aldehyde name is butanol. So A is butanol. So we have butanol there for A, and then we have to come to B. B there, let us go to B and see what B is like. You always go to B, and so that's the structure there. So we can name it from the structure. It's a alkene group, and then we can see it has double bond, and then have 4 carbons, and then have branches in carbon 2 and 3. So on those branches are methyl, and then the carbonyl function ends with ENE, which is an alkene. Then from there we can go and name. So we go and naming, that is going to be 2,3,3. Those are placeholders for the methyl group, and there are 3 of them. That is trimethyl. So trimethyl, 1N, so which means it's bonded to the first carbon. Alright, so 1N. If the first is bonded to the second, then we take the first. And that's 1N. So that's how 1 butene, 1 butene, not butane. I think it's supposed to be EN. 1 butene. And then there's 2,3,3 tribute 1N. So we need to know where the double bond is. It's on the first carbon. So but 2,3,3 tribute 1N, or trimethyl 1 butane. So that's C. So let us see what C is comprised of. We have to look at function C. So let's say they are functional isomers, so which means the other one is aldehyde, the other one's supposed to be ketone. So let us draw the structure first. So that C4H8O, and then that means we have C, the 4 carbons. So which means the first one was aldehyde, then the carbonyl group has to be somewhere in the middle. So we're taking it to carbon 2, and then that is aldehyde, and that's the structure for ketone, which is the same formula group with aldehyde. And then going to 2.4, we have type of reaction that D is used to form F. So D is alcohol, and then F is ester, and then we know that ester has to be the combination of alcohol and carboxylic acid. So the process is esterification. So it's esterification, but because also it gets rid of water, so it's also called condensation. So it's condensation or esterification. So that is the name, the type of reaction. So IUPAC name for D is the alcohol, so that is alcohol there, and that is 3 carbons, that's propanol or prop 1 on or 1 propanol. So you can just use different standards for naming from the IUPAC, and then that's 1 propanol with OL. Structure for the organic reactant, okay, that's esterification there, that is 2.4.2, and then the second one IUPAC name for D, that's propanol, and then 2.4.3 we need to find the structure of the organic reactant used. So that's propanol, and then coming to the structure, we know that it's going to be ester, it's going to be carboxylic acid, so that is going to be carboxylic acid and alcohol, so we need to find the structure for the carboxylic acid and the alcohol. So we know that this is butanoic because it has 4 carbons, butanoic acid. After just the ester bond, we need to include H there, and then that is carboxylic acid, as we stated before. Then after the carboxylic acid reacts with the alcohol, and then we need to include the structure, because that's what they want. So the structure will mean that we have how many carbons there? We have 4, so that means that we have 4 carbons attached to each other, so C, C, and C, and then carbonyl on the last carbon with the OH. Okay, so we fill up with hydrogen on the rest of the carbons to create the carboxylic acid. So that's how we draw this. So knowing how to draw the structure is very important to naming the compound, and then from there that's the other reagent. So that is our answer for 2.4.3. And 2.4.5, that's propyl butanoic acid. So that's how we name it. Thank you for watching, and don't forget to follow or subscribe. Thank you.